In this video, we'll take a look at some of the problems in Chapter 7. So these are some problems that have traditionally given students trouble. All right, so you should not watch this video till you've already tried to work all these problems. As far as, let me say one thing about the true-false questions. So when you come to a true-false question, Lane is just going to tell you whether the answer is true or false. If you get a false answer, what you should then do is take a look at the question again and say, okay, how can I change this question to make it true? All right. Well, there are three questions that I want to take a close look at. So we'll start with, most of these are pretty similar to examples that I work in the PowerPoint and that I work in the little video where I go over that PowerPoint. So you can always refer back to that to figure out how to work a lot of these. They're really not that different. But there's a couple that are really important and a little bit tricky. So we'll take a look at 4 first. Okay, so let's read number 4 here. So what proportion of a normal distribution is within 1 standard deviation of the mean? Okay, well, one thing I didn't mention earlier, but you might have found out, is these numbers in a standard normal distribution, those are actually standard deviations from the mean. So for example, the 1 here, that is 1 standard deviation from the mean on this side. So with a question that says what proportion is within 1 standard deviation, what we're looking at is the area between -1 and +1. Now, this is actually an important relationship that everybody should learn about in statistics. And it's illustrated, hold on, let's see, illustrated in this little graph I have in this PowerPoint. I believe I put this in the introductory PowerPoint in Unit A. But this is a distribution, a normal distribution, and 1 standard deviation from the mean is going to account for about 68.2% of the area. Notice 2 standard deviations is about 95.4. This is actually going to be really important knowledge for you guys when we get to other parts of this course, like estimation, which we have coming up soon. Okay, so let's take a look at how we would solve these problems. All right. So within 1 standard deviation, what we want is the area between -1 and 1. So we would put between, and then we would need to enter, let's see, oh, I'm sorry, hold on, this is the wrong calculator. We need the normal distribution calculator to find this. All right, there we go. And again, you need the standard normal distribution calculator. All right, so we need between 1 and, I'm sorry, you want to do -1 first here, I think. And 1, there you go. Okay, so notice we've got the area between 1 and -1 shaded. And just like on my little graph before, you can see the area is 0.682. Okay, now let's look at some of these other questions. So B asks, what proportion is more than 2 standard deviations from the mean? All right, so for 2 standard deviations, we'll just change this to -2 and +2. All right. Now this isn't the area that's more than 2 standard deviations. That is 2 standard deviations from the mean. So as you can see, the area of that is about 0.9545. So if you want to know the area that's more than that, so it depends on kind of how you read this question. Like if you think of more being a positive value, it would just be that little area there, which is about 2.5%. But if you want to read it as like extreme, like beyond this, then it would be 5%. And I believe that's the answer that Lane puts. Now, we can get that from the calculator. If you want to get something with more decimals, you just select outside here. And you need to change this to -2 and 2. All right. And then that gives you the answer. So 0.046 would be the correct answer for that one. All right, now let's see what this last one here says. What proportion is between 1.25 and 2.1 standard deviations above the mean? Okay, so for this one, I believe we're looking at just the area above it. So 1.25, and what was the other one? 2.1, okay. And 2.1. Okay, so there's that little area for that region, 0.088. Okay, and you'll find that those answers all match what Lane has here. Remember, on quizzes in this class, we'll always be including 3 decimals, so he's rounded off B here. All right, let's see here. Now, the other one I want to look at is 8. So let's scroll down to 8. Okay, so here we have kind of a somewhat real-life relation, I guess, scenario. Assume that the speeds of vehicles along a stretch of I-10 has an approximately normal distribution with a mean of 71 and a standard deviation of 8. Okay, so mean of 71, standard deviation of 8. Okay. The current speed limit is 65. What is the proportion of vehicles less than or equal to the speed limit? So we want to know, like, who are these slow drivers? How many of them are there? All right. Now, that's not the mean, right? The mean is 71. So what we want to do is model what people are actually doing and then figure out how many of them or what proportion are going slower than this. All right, so remember, that's sort of what this is. This is a model of what people are doing. So what they're actually doing, they have a mean of 71 and a standard deviation of 8. Okay. Now, we want to know how many people, or what proportion of the people out here are going less than 65, like less than the speed limit. All right, so you can see that the answer would be 0.227. Okay, all right, so there's the same answer we have for Lane's question. What proportion of vehicles would be going less than 50? Well, okay, change it to 50. A speed limit will be initiated such that approximately 10% of vehicles will be over the speed limit. What is the new speed limit? Okay, so now we have a little percentage here. So we're going to need to figure out what the speed limit needs to be. Remember, this is what people are actually doing. Okay, so we're going to change that number. So what would it be? Okay, well, again, we got to model what people are doing. And then we got to find the score on the x-axis that would correspond to 10%. So we're going to need the inverse normal to do this one. All right, so we'll go to the inverse normal distribution. Again, let's model it. So we're interested in 10%. All right, 0.1 there. We have the mean of 71, right? And standard deviation of 8. So that's what people are actually doing. All right. There's the 10% cutoff. Okay, so the answer would be 81.252. Now, obviously you wouldn't put all that on a speed limit sign, but we'd need the speed limit sign to say 81. Let's see what Lane put over here. Yeah, okay, well, he even did that, or if you round it off. Okay, let's see what D says here. In what way do you think the actual distribution of speeds differ from a normal distribution? Well, there's really no way to answer that. I mean, it's more like a an opinion thing, I suppose. So there's really no correct answer for D. All right. Okay, now we'll take a look at 25. So this is the one I warned you about. This is the one where you're going to definitely need to use the standard normal distribution. So let's take a gander at this one first. Okay, let's see what we got here. So suppose that weights of bags of potato chips coming from a factory follow a normal distribution with a mean of 12.8 ounces and standard deviation of 0.6. So what the manufacturer wants to do, he wants to keep the mean at 12.8, but adjust the standard deviation so that only 1% of the bags weigh less than 12 ounces. Well, wait a minute. None of these, so we're trying to find out a standard deviation. Neither calculator gives you a standard deviation. So what you need to do then, you need to find a formula that has got standard deviation in it. That's the way you want to look at a problem like this. Okay, so neither calculator will actually give us a standard deviation. That's something we normally have to put into the calculators. So we need a formula that has got standard deviation in it, and then we can try and play around with some of these numbers. So I already gave you a hint for this one that you would need the standard normal distribution. So let's take a look at it here. Okay. All right. So this is the formula we're going to be using. So what it's got various scores that we have, like we've got the mean, we've got it. What we want to find is a standard deviation. So we just need to figure out what are these X and Z scores going to be. Well, let's take a look at the standard normal distribution first. So this is what, and again, it's got a percentage in there. So we're going to work with that. So this is what this guy wants to happen. So he's interested in values less than 1%, so below something here. And then we're going to need, if we're going to use that transformation formula, we're going to need to be working with the standard normal distribution, which has a mean of 0 and a standard deviation of 1. Okay. So on a standard normal distribution, like you see here, 1% of the area of this corresponds to that number. Now remember, we can take a standard normal distribution like this and scale it up to be any normal distribution. And that's what that Z formula does for us. So this is a Z-score. Remember, these are a Z-score? What we have in the question are X scores. So let's take a look at this. So what he tells us is, he tells us a mean, and then he tells us a percentage, and it says 1% of bags weigh less than 12 ounces. So it's just like if we had a distribution like this, 12.6. You see what I mean? And what we want to know is, like, you have to put in a standard deviation, though, and the standard deviation is what we're trying to find. So we don't know that, but that's going to be an X score, and he tells us that that X score is 12. Okay, so you can't use, like I say, you can't use this calculator. What we need is to use this formula here. So this is how you do it. All right. So the first step we did is we need to find a Z-score that corresponds to 1%. And we found that just a minute ago with the calculator. That was negative 2.326. So I used the standard normal distribution. I put in 1%. This is the Z-score. So 1% is below that number. All right. Now, what we want to find is we want to find a value on the potato chip graph that corresponds to that Z-score. All right. In other words, well, we want this to equal that Z-score, and we want to know the standard deviation that'll give us that relationship. So now we can plug things into this formula. All right. So what I've plugged in, there's the z-score. All right. This is the x where we want to equal that z-score. All right. There's the mean. Okay. Now all that's left is one unknown variable. So we just use some simple algebra to find this. So you can cross multiply. So you have negative 2.326 sigma equals 12 minus 12.8. So we wind up with playing around. It's basically going to, we're going to lose the sign here, and will be 0.8 divided by 2.326. So we've got to solve for this, right? So if you do that in the calculator, all right. Okay, let me just clear that out. 0.8 divided by 2.326, right? And, those would both be negative, but you can, of course, lose that if you want. All right, and there's the answer. That's the same answer that you have in the guide. So that's how we find the standard deviation of that one. Okay, let's look at one other thing. Maybe you read this already and you're like, well, I don't understand this question. Nobody does. Question 27 here. It's completely flawed, so just ignore it, If you kind of look at the answer, what does it say? Most cars are likely to be traveling within 5 miles per hour of the speed limit. I don't know how you're supposed to guess that. It certainly isn't the case in Florida. Okay, so with that, we will end this video on, and I hope that the other problems in here are relatively easy for you. You can always send me text messages if there's one or two others that you couldn't quite figure out, and I can probably help you with it. But I think between this video and the introductory video and a little maybe going back and forth to Lane's chapter, you should be able to get most of the other ones.